A warm welcome to the module on vapor pressure and boiling point of liquids. We have learned the characteristic properties of liquids. Now we shall think about some of the important physical properties such as vapor pressure, boiling point, surface tension and viscosity. In this module, we shall discuss about vapor pressure and boiling point. I will show a video which indicate the transformation of liquid water into water vapor. You all have to observe it and say what you can see in it. Yes, we can see that water particles on the surface of the liquid get moving into the vapor phase. And you can see that since the beaker is closed, with the lid, the particles will strike on the walls of the container. So what will happen? Yes, the vapor exerts a pressure due to the collision of vapor molecule on the surface of the container. When a liquid is heated in a vessel closed with a lid, and after some time you can see that some vapors are started condensing on the lid. So on heating water in a vessel closed with a lid, you can see two processes are take place simultaneously. Which are they? Yes, it is vapor forming process that is called vaporization, and the conversion of vapor into liquid called condensation. So the two processes are vaporization process and condensation process. Now we shall think about the rate of these two processes. And what will happen to the rate of these two processes as the heating of the liquid progress? What you can say from your experience? Because you have experienced these two processes, that is vaporization and condensation. Yes, we can say that the rate of these two processes first increases and reaches a maximum, and then the rate becomes constant. Will you please tell me the name of this stage reached? Yes, it is called equilibrium stage. That is, the rate of vaporization becomes equal to the rate of condensation. Or we can say that at equilibrium, the rate of vaporization becomes equal to rate of condensation. So we understood that two processes, vaporization and condensation, are take place in equal rate and an equilibrium is established. At this time, the pressure exerted by the vapors on the surface of the liquid is called the vapor pressure. So vapor pressure of a liquid is the pressure exerted by the vapor on the surface of the liquid at equilibrium. Now we shall think about the boiling of liquids. When a liquid starts boiling, have you any idea about it? Yes, it has some relationship with the vapor pressure. So we shall think about the change in vapor pressure. You can see that vapor pressure is increasing with the temperature, and finally a stage is reached where the vapor pressure becomes equal to atmospheric pressure. At this stage, liquid starts boiling. So what is the boiling? When the vapor pressure becomes equal to the atmospheric pressure, the vaporization can occur throughout the bulk of the liquid and the vapors expands freely into the surrounding. The condition of free vaporization throughout the liquid is called the boiling. So you have to try to define the boiling point of a liquid. The temperature at which vapor pressure of a liquid is equal to the external pressure is called the boiling temperature or boiling point of the liquid at that pressure. So we understood that boiling point is related to atmospheric pressure. We know that different units are used to measure the pressure. What are they? Yes, atmosphere, bar, etc. The boiling point is termed differently under these units of measurement, and they are standard boiling point and normal boiling point. Let's see the difference. At 1 atmosphere pressure, boiling temperature of the liquid is called normal boiling point, or we can say that normal boiling point is the boiling temperature at 1 atmosphere pressure. If the pressure is measured in 1 bar, then the boiling point is called standard boiling point of the liquid. The standard boiling point of a liquid is slightly lower than normal boiling point of the liquid. Why? Because 1 bar pressure is slightly less than 1 atmosphere pressure. So the normal boiling point of water is 100 degrees Celsius or 373 Kelvin, and its standard boiling point is 99.6 degrees Celsius or 372.6 Kelvin. Now let's see some interesting cases. The first case is regarding the boiling point of liquid at high altitude. Do you know about the atmosphere pressure at high altitude, or what is the value of atmospheric pressure at high altitude? Yes, at high altitude atmospheric pressure is low. So what happens to the boiling temperature of the liquid? The liquids at high altitude boils at lower temperature in comparison to the sea level. Let us see some practical applications of it. Since the water boils at a low temperature on hills, the pressure cooker is used to cooking food. In hospitals, surgical instruments are sterilized in autoclaves, in which the boiling point of the water is increased by increasing the pressure above the atmospheric pressure using a weight covering the vent. Now let's see another interesting case. That is, boiling does not occur in closed vessel. Have you heard about it? Anyone knows the answer? I will explain. On heating liquid, the vapor pressure is continuously increases. At first, a clear boundary is visible between the liquid and vapor phase because the liquid is denser than vapor. As the temperature increases, more and more molecules goes to the vapor phase and the density of the vapor rises. At the same time, the liquid becomes less and less denser. It expands because molecules move apart. When the density of the liquid and vapor becomes the same, a clear boundary between the liquid and vapors disappear. And this temperature is called a critical temperature. So we are saying that boiling will not take place in closed vessel. I think vapor pressure and boiling point terms are very clear to you. Thank you, dear students. Thank you. We will meet in the next class.